the expert on driverless cars, Dr. Larry Burns.
Thank you very much. Can you hear me okay in the back? That's great. It's important that you can hear me. 18 years ago, I woke up in the middle of the night and I lost my hearing. And I lived deaf for a year, and now I hear with this amazing technology called a cochlear implant. So during Q&A, I may need a little bit of help, but I should be just fine with that. You know, living in that world of the hard of hearing has its moments. I was with my wife recently. We were down in Florida, and we came upon this town called Kissimmee. And I said, look, honey, we're going to go to Kissimmee. And she said, well, it's really not pronounced Kissimmee, it's Kissimmee. I thought, well, I thought it was Kissimmee. She says, well, I can hear and you can't hear. And I said, well, why don't we stop and ask someone? So we went to a restaurant, and I walked up to the waitress, and I said, excuse me, can you tell us where we are? And my wife said, say it real slow because he can't hear too well. And the waitress goes, Burger King. So anyhow, it does have its moments. What I'm going to do today is talk to you first about the history of the automobile quickly, tell you how that DNA of the car is changing dramatically, and then ultimately focus in on driverless shared vehicle systems and what I think that means to the connected electronics industry. If you go back to 1886, Carl Benz received the first patent for a gasoline-powered automobile. And, you know, it was a phenomenal invention, and a lot has been done since that first invention, like steering wheels and closed bodies and automatic starters and power steering and turn signals and automatic transmissions and catalytic converters, direct injection seat belts. And you start getting into things, I think, that are beginning to get into your sweet spot, like cruise control and anti-lock brakes and electronic stability control and navigation systems and telematics, the first modern electric vehicle, and very, very importantly, what we're seeing now with adaptive cruise control, lane keeping, and what I'm going to discuss in more detail, cars that literally drive themselves. So yes, a lot has happened to that first automobile, but its DNA, its fundamental makeup has pretty much remained the same. I would contend if you were an archaeologist and you dug up a 2000 vintage car and you also dug up a 1900 vintage car and you compared the genetic makeup of those vehicles, you'd say they're pretty much the same. Mechanical drive with a combustion engine, oil-based mechanical and hydraulic controls operated by a human as a standalone machine, and general purpose. And it's been remarkable in terms of the freedom that it provides. It lets you go anywhere, anytime, with others and with goods, in a broad range of capabilities, from stop and go to continuous driving, and from light loads to heavy loads. And I think it's not then surprising to all of us that there's 1 billion automobiles on the planet, because those of us who are fortunate enough to experience one realize how much freedom we have. Now, to put that number 1 billion in perspective, if you park these cars end to end and wrap them around the planet, they go around 100 times. So we have a lot of cars and trucks today in the world, and that's at the heart of the challenges that we face with this technology. From the standpoint of safety, there's 1.2 million people a year dying on roadways. These are pedestrians, bicyclists, and people in vehicles. That's epidemic in scale. We're 95% dependent on oil as an industry. Traffic delays are frustrating for us. They also result in reduced productivity. We use our land for things like parking. We have environmental concerns with climate change, and our infrastructure is aging and costly. So we really need to ask, is the system that Benz and then later Ford really popularized, is it really going to be sustainable without transformational change? We've had great evolutionary change, but can we sustain this without transformational change? And there's a lot of reasons to believe that this change is needed. This is a busy chart: energy, economics, and security, and oil and gas price volatility. We're living through another spike right now. Globalization, urbanization, and technology. But for you as a group, the one message I want to leave you with is business opportunity as the primary reason for change. And it's an enormous business opportunity when you think about roadway transportation, not in terms of building and selling new cars and trucks and features on new cars and trucks, but in terms of selling miles, trips, or the experiences when you're in your vehicle. There's 3 trillion miles a year traveled in the United States on roadways. And if you could find a way to just make a penny a mile, just a penny a mile off of every mile, you'd make $30 billion a year. So that puts you in that profit world of an Apple or an ExxonMobil. So that's an enormous opportunity. Now, how might I calibrate that penny a mile? A median income person in the United States makes $50,000, and that's $25 an hour. And when you travel at 30 miles an hour, it's 85 cents a mile. So a penny a mile is 30 billion a year, and the time value of a median person in the U.S. is around 85 cents a mile. So if we can't find a way to make some good money off of transforming the fundamental business model behind roadway transformation, kind of shame on us. And I think the opportunity really is around fundamentally transforming mobility. There's a whole new DNA that's emerging. And part of my message today is think about this not as individual technologies, but how all of these are coming together with electric drive and electric motors, diverse energy sources, electronic and digital controls, driverless vehicles that are connected and coordinated through a massive coordination system involving big data, vehicles that are shared and vehicles that are designed with specific purpose in mind. All of that combined, that new automotive DNA, I think, is a significant growth opportunity for your industry. So when I was invited to speak, I was excited to share the story of where this new DNA for the automobile is headed. Let's start with vehicle production. And I'm sure you're all familiar with the alphabet soup of HEVs, PHEVs, EREVs, and FCEVs. And really what we're seeing, quite honestly, is just a transition from pure mechanical power on the vehicle. The left side of the scale is that, 100% mechanical power, to the right side of the scale being 100% electrical power. And in between we have mechanical cars with electrical assist. Those are hybrids. And we have electrical cars with mechanical assist like the Chevy Volt. And ultimately, we have the pure plug-in electric vehicle like the Nissan Leaf and the fuel cell electric vehicle. All of these will be in play. All of them require very, very sophisticated power electronics and controls and energy storage systems. And given the stringent regulations for fuel economy and emissions, we'll see these all getting introduced in greater quantity as the industry continues to grow. The good news about splitting between mechanical and electrical drive is it makes the energy story a little bit simpler. On the left side of the chart, we have all these different primary sources of energy. And as I said before, we're 95% dependent on oil, which is not a good place to be. But all these other pathways can either make their way into a combustion vehicle with mechanical drive or an electrical vehicle, whether it's a battery electric or a fuel cell electric. So we do have some exciting opportunities, especially with the plentiful natural gas that's being discovered through hydraulic fracturing to really get at this energy issue. But the technology that will fundamentally change more than anything else is this opportunity for a driverless car. This is an engineer's dream. And I'm assuming, how many of you here are engineers? I'm an engineer. Most all of you are engineers. I went through the definition of an engineer as someone that likes to work with numbers but doesn't have the personality to be an accountant. I don't know. I don't think that's fair. And then I heard there are two kinds of engineers. An introverted engineer looks at his shoes when he talks to you, and an extroverted engineer looks at your shoes when he talks to you. These driverless cars are phenomenal. Let me tell you just the story of the upper left. That's a vehicle. It's a Chevy Tahoe, and we called it Boss. And while I was at General Motors as head of R&D, we teamed with Carnegie Mellon University to enter what was called the Darpa Urban Challenge. Darpa put a $2 million first prize on the table for any team that could create a car that could go 60 miles in a city setting in less than 6 hours. Totally autonomous, nobody in the vehicle, no remote control. Now, GM had hit a financial wall. We needed the $2 million pretty bad, so I decided we'd enter this and try to win it. There are actually 85 teams that entered that race, and I think that's the big part of the story. And we went to Victorville, California for the finals. 35 teams built cars that passed the driver's training test, and then in the finals, 11 qualified for the race on the final day. It was covered by ESPN. It was really exciting, and our car with Carnegie Mellon happened to win. That car was like an X Games athlete. We calculated that if we accelerated aggressively and braked aggressively, we could save about 6 minutes, and we did. And Stanford and Volkswagen was like a figure skater. It was a beautifully smooth, precise machine. We beat them by 20 minutes, but it was a very exciting race. Two of the spectators for all 3 days in California, were Larry Page and Sergey Brin. And they just mixed with the teams, not just the winning teams, all the teams, and they ended up hiring 15 of these engineers, and they equipped 9 Priuses with self-driving technology. And you might think, how can this possibly be safe? By the way, I'm from Detroit. If you're ever in Detroit and you need to know where to be safe for a tornado, go to the Detroit Lions end zone because nothing ever touches down there. So here's what Google came up with. This is shot out of the front of one of those Priuses. The car is driving itself. Google figured out if I had someone sitting in the front seat, the law said I had to have someone there. I didn't have to touch the steering wheel, brake, or the accelerator. So these are engineers and technicians accumulating these miles. They've now accumulated 300,000 miles with this technology. You can see the laser on the top of the vehicle. It's spinning at 10 hertz, and it's doing 1.5 million measurements per second. We also have radar on each of the corners of the cars, cameras. The cameras are actually handling more data than the laser. And then we have sort of a typical laptop quad-core processor that's handling all of this data. This is going down Lombard Street. You recognize that in San Francisco. This is the car operating through a construction zone. And what Google does is they'll first map this using the Street View system, and then they'll take all of the data coming in from the lasers, the radar, the cameras, and they fuse all of that information so you can begin to get a sense of just how massive the database is. And they begin to categorize what they're seeing, and they can see it either as a vehicle, a pedestrian, an inanimate object, and then they make sense out of that, and then they can give input to how fast the wheel should be steering or spinning and the steering inputs and the braking inputs. So that's sort of the technology in a nutshell. And it's working remarkably well. As part of my role in advising Google, I go to Mountain View about once a month. I ride in the vehicle on 101, and I'm going farther and farther every visit, and it's very, very intuitive. It's really impressive, the progress that's being made. So the technology alone is exciting, but why is this going to be so important for the reinvention of the automobile? First of all, people get more value for their time in their vehicle. Again, as an automotive executive, and I don't mean to be flippant with this, very, very concerned about driver distraction. But quite honestly, I became convinced that a lot of consumers see driving as the distraction. Why else would they drive a 4,000-pound machine at 70 miles an hour and send a text message, unless they thought that text was more important at the time than to drive safely? So people really want to be freed up from being tethered to the steering wheel. And that, by the way, once you do that, really it gives you some opportunities to change the design of the car dramatically. In order to get to this world of driverless cars, we're going to have cars that don't crash. And we'll be able to show empirically, we're doing that already, that driverless cars are safer than human drivers. And then finally, a car that doesn't crash can be designed to be much, much lighter. And lighter vehicles are much more amenable to batteries. The Chevy Volt has a 16 kilowatt-hour battery. The Leaf has a 24 kilowatt-hour battery. The Tesla Model S upscale, the one that claims to go 250 to 300 miles, 85 kilowatt-hour battery. The Volt battery is the size of an offensive lineman, 6 foot, 390 pounds. Now, if we can get our vehicles from 3,000 to 4,000 machines down to 500 to 1,000 pound machines, the battery begins to make a lot more sense. I'll show you some examples of those designs in a minute. Now, these driverless vehicles, in my mind, do appear to be inevitable. I think one of the principles of strategy is if you think something's inevitable, get in front of it. Companies like Google, Daimler, Volvo, GM, Toyota, Volkswagen, BMW, Bosch, Continental, Delphi, I'm sure some of your companies are working this area very, very hard. The timeline is, from a technology standpoint, really proving that we can do it. A car that goes anywhere, anytime, looks like it's in that 3 to 5 year time frame. We're making great progress, but go anywhere, anytime is an ambitious goal. Parking lots, quite honestly, are very ambiguous places to have robotic cars. The things that's going to gate this in terms of it turning into big markets for your companies will be things like regulations, liability, standards, consumer acceptance, and the vested interest of all of the players that have big investments in how we move around and interact today. The pathways that I think are likely going to surface is it'll be an option. It'll be what's called a self-driving feature. You're sitting in the driver's seat. It'll be like a cruise control on steroids where you can hit a button when you're on 101 and travel maybe 50 miles without having to do any driving work. Daimler has their Distronic Plus steering assist system. GM has Super Cruise as examples. Then I think you're going to see driverless systems, really truly robotic, where the car can move without a person in it on campus-type settings, gated communities, college campuses. And then the bookends of all of this, the expressway driving and the parking lot, will begin to converge from the two ends inward, and we'll get there. So it looks inevitable with a lot of attention being given to it. The hardware, as I mentioned before, are lasers and radars and cameras and processors and displays, and then the electric acceleration, braking, and steering systems, all areas that will become growth opportunities for your industry. Then we have these vehicles now that are highly electronic, and they have communications capabilities and transponders. Now we can start getting into the world of really big data and manage what we call the mobility internet. This is the internet of things that want to move around and interact. So much like the information internet, which did it for information, will do for vehicles what information did for computers with the mobility internet, with precise coordination, optimal traffic flow, and capacity utilization of roadways, parking, and intersections. Many companies are working in this connected space. I won't name all of them. I'm sure many of you are familiar with all of these different players. So connectivity is not something new. In fact, it's beginning to mature considerably. Now, the next piece that's starting to come together is shared vehicles. This graph may be a little hard for you to read, but on the vertical axis, we're plotting the percent of personally owned vehicles that are on the road at any given time of day. And there was a major study done in 2009 by the Department of Transportation. It's a household travel survey, and this is what this data is taken from. And then horizontally, we're plotting the time of day. And all the lower lines are different types of trips: social, personal, business, shopping, commute. And then the red line are all trips. And what's important to note is, yes, there is peaking, but even during the peak, only 12% of the vehicles are on the road. 88% of the vehicles are parked, even during peak hour. And you ask yourself, if you were in a manufacturing business and you had a piece of equipment that said idle 88% of the time, would that be a pretty wise investment? Probably not. But as consumers of mobility, we're all content to buy this car and let it remain parked most of the time. Now, there's a lot of startup companies who see that changing. In fact, 25 new entries in the last 10 years in things like car sharing, ride sharing, taxi service, and taxi apps. And I've listed some: Zipcar, Uber, Halo, Relay Ride, Zimride, Hertz. Avis just bought Zipcar. So the big players are getting serious about car sharing as well. Now, finally, the next building block of this transformation are special purpose vehicle designs. These are vehicles tailored to the driving cycle, duty cycle, and trip characteristics. That database I talked about earlier, 90% of those automobile trips had just one or two people. But most of the cars we buy have 4 to 6 person occupancy capability. And most of our trips, especially when we're not on the highway, are 15 miles per hour to 25 miles per hour on average. But yet our cars can go 120 miles an hour. So you begin to think maybe the car's a bit over-designed for the typical trip, and if we could tailor the design of the vehicle for the typical trip, we could make things more efficient, spatially, energy, time-wise, and cost-wise. And here are some examples of concepts of cars of this type that have emerged at auto shows over the last decade. The one in the middle is especially near and dear to me. It's called Autonomy. When I became head of R&D in 1998, my boss, Rick Wagner, said to me, he said, "Larry, if you're going to invent the car today, rather than 100 years ago, knowing what we know about technology and about the issues of the car, what would you do differently?" And that's that concept. It has electric wheel motors. It has energy storage in the chassis. The body docks on like a laptop does on a docking station. And that's the kind of question that's pretty profound. I got in a discussion with my wife the other night and asked her a question. And I said, if anything ever happens to me, do you think you'll get remarried? She's a little bit younger than me. And she said, "No, I couldn't do that." And I said, "Well, you'd still be young, and it just seems like you should." And she says, "Oh, okay, I'll think about it." And I said, "Well, if you get remarried, you're going to let this guy have my car. I've got a Cadillac XLR. It's like a Cadillac Corvette. It's really pretty neat." And she said, "That's your pride and joy. I can't let him have their car." I said, "I'd be gone. The car would be in the garage. It just makes sense." And she said she'd think about it. I said, what about my golf clubs? And she goes, oh, no, he's left-handed. So you don't know what you're going to get when you ask a question. Now, here's actually how I answered Rick's question. The transformation that we see is going to be an integration of the advanced propulsion, the connected and driverless technology, this new DNA, and then a mega trend toward urbanization where most of the wealth is getting concentrated in cities. We'll have smart energy, we'll have the mobility internet, and we can put all this together to truly transform mobility. And this next video gives you a sense of what that could look like. GM was given the pavilion rights to the Shanghai World Expo. In 2010 is when that expo was held. We had 70 million visitors. And I was asked to come up with, well, what are we going to put in that expo that could embody better city, better life in the year 2030 in Shanghai? So we teamed up with Segway. We widened their balance machine. We put all of these advanced sensors on this vehicle so it could drive itself, communicate with other vehicles, and created this vision and played that out on the pavilion. If you want to travel with more than 2 people as a group, you can platoon. If you want to have priority to emergency vehicles or other vehicles on the roadway, they can communicate with each other and be given that prioritized treatment. If you want to move more vehicles through your urban area, you could totally rethink intersections. This is one of those moments where, but yet our airplanes guide through space-time paths, and it's the convergence of the technology that makes this kind of opportunity possible. Beyond that, if we want to communicate with bigger databases, we can tie into the cloud. Because these would be envisioned as 500-pound machines, we can think about 3 to 5 kilowatt-hour batteries. And since they're 3 times as efficient, we can have a dramatic improvement in efficiency. The story behind the pavilion involved a woman that was blind, and we showed how that could provide access. This is a creative idea from the Chinese team. Not sure if you had a big gulp in your car that this would work right, but it's an interesting idea for parking. The point we're trying to make here is this convergence of technology takes us from the car being something you drive to something you wear, from being something you park in your garage to something you could park in your closet. And that's really what we think is possible. It's a holistic opportunity. It's not one thing. It's all of these things combined that give us a chance to have better mobility experiences at radically lower consumer and societal cost. How much lower? Let's start with 15x. I talked about the mass of the vehicle being reduced. We think we can get it down by about a factor of 5. Electric drive is 3 times as efficient as combustion drive. 3 times 5 gives you the 15x. A lot of politics around CAFE, and we've taken CAFE up to 54.5. We basically doubled it. And this world is a world that's dramatically bigger opportunity. I would contend the single most important thing we can do on the energy and climate change front of mobility is to get to driverless vehicle technology. A 10x stands for the cost reduction. We see this having about 1/10 as many moving parts and far less mass, about 1/5 the mass. So you can begin to appreciate how much less costly this can be. You combine that with shared driving systems, and I'll illustrate that in a second. It becomes profound. 5x, we can park 5 of these in the space required to park a typical car. Manhattan, about 20% of the miles driven are people looking for a place to park. And so I think and only 30% of the people in Manhattan own a car because of the congestion and the hassle of owning it. I think the most important metric, though, is 0x. These are fatalities. We think we can get the crash out of the system through the driverless technology. It's really an engineer's dream. It kind of reminds me of the story of a young engineer and his wife had just had their first baby, and they brought her home from the hospital and put it in the nursery, and that night he was in there looking down at the baby, and the wife walked into the room up behind him, and he had this look of awe on his face, and she just had this emotional moment, went up and hugged him and said, "A penny for your thoughts." He goes, "This is the most amazing thing. How could they possibly have designed and built this crib for $85? So that's what engineers do. We get the cost out of things, and it's pretty exciting. So what really might be possible? I want to get you into this future world of how you might be moving around. Think about shared fleets of vehicles, 1 and 2 passenger cars for most of your everyday movement, some bigger cars for family trips, and maybe light-duty trucks for loads. The right vehicle would arrive at your door, right at your origin, when you need it, take you to your destination, and you can use your time as desired, not distracted by the need to having to drive. That vehicle then goes to the best next location to serve someone else. And the whole name of the game in designing this mobility system is to size that fleet of shared vehicles, coordinate them to give you even better accessibility than owning your own car, meet your same travel demands, do it with far fewer vehicles that are tailored for their purpose, highly utilized with minimal parking, and then you got to optimize these empty miles. You don't want to be moving these cars around empty too much. And we've done some case studies to get a feel for this, but first let me give you a sense of how it might work. We've used this term be driven, so imagine you have this shared system in your community, and you've logged on to it, you have access to it, and you want to ride. So one button, you hail a vehicle, not stand on the curb when it's raining, waving at a cab, or making a phone call and wondering if the dispatcher actually understood where you are. This knows where you are because of your GPS and your handheld device. You choose your destination. Oftentimes that would be a convenient menu that you would pick from because we typically are creatures of habit on where we go. The dispatcher comes back and says the vehicle's on its way. It's going to be there in 3 minutes. It's 1.1 miles away. It keeps you informed when it's going to arrive. It picks you up, downloads a security code so that you can get into the vehicle. It then tells you that your estimated arrival time is 3 minutes. It's 1.1 miles away. Keeps you informed. It provides you with entertainment and services along the way en route. And basically, that's how the system would work. Very, very user-friendly. Now, the question is a great idea, but couldn't you make money off of it? Is there a business here? So we've looked carefully at Ann Arbor, Michigan. Ann Arbor is representative of medium-sized cities in the United States. And the results for Ann Arbor are similar to Austin, Sacramento, Orlando, Rochester, Salt Lake City. It's that kind of a city. And here we're comparing to personally owned vehicles. So could I give you a mobility system of the type I described instead of you owning a car? Then we looked at Manhattan taxis and a densely populated urban area where you'd be competing with an existing mode called the taxi. And then Florida communities, these gated communities are of great interest because the roads are very, very friendly to driverless vehicles as a first-generation play. I'm going to just touch on 2 of these examples. In Ann Arbor, there's 285,000 people and 130 square miles. They own 200,000 cars in total. They take about 4 trips a day that are about 8 miles on average in length, at about 30 miles on average with miles per hour average with 1.5 people, and they use their cars about an hour a day. The results of simulating this system for a place like Ann Arbor, having the right mix of 2-4 passenger vehicles, we need about 18,000 vehicles instead of 200,000. It would cost about $3 per day per subscriber. The vehicles would be responding typically in less than 2 minutes when you request a ride, and the empty miles would be about 0.02 per loaded mile. Pretty exciting results. We think there's a good match. That's because of the trip origin and trip completion densities within a community designed like Ann Arbor. In Manhattan, that's 1.6 million people and 23 square miles with 410,000 taxi trips per day. These trips are about 2 miles in length. They average about 11 minutes at 11 miles an hour. Takes you about 5 minutes on average to hail a cab. And these cabs travel about 0.6 of a mile empty for every loaded mile. We think we can replace that 13,000 vehicle fleet with 9,000 vehicles, take the cost down from $7 to $1, get to you in 1 minute rather than 5 minutes, and get that empty miles down to about 0.05 versus 0.6. So both of these studies are very, very encouraging in terms of the potential to make a business case out of this. So let me begin to wrap up. My bottom line here is that roadway transportation is truly ripe for transformational change. The convergence of the technology and these innovative business models really do promise better mobility experiences at radically lower consumer and societal cost. It's a significant business opportunity, and the incumbent players really, quite honestly, are at risk of being disrupted. If you think about industries like photography, media, entertainment, computers, telecom, television, pharmaceuticals, these are all industries that have been disrupted dramatically over the last 20 years. and the incumbents rarely do well when industries disrupt. Think about Kodak. They invented digital photography, electronic photography, yet they couldn't make the business model transformation to get in front of this and turn it into a winning business. The winners, when you go through this kind of change, must focus on creating, in this case, innovative mobility systems and services. This isn't just about designing, engineering, building, and selling cars or features on cars. It's a whole rethink of how we move around and interact. Designing compelling and consistently positive experiences for the customer. Think about all the things we can do now to serve the customer every mile, every trip with every experience. You deeply need to understand the customers, and we need to understand those things that are negative about today's system. So most people don't like to stop to buy gas. Most people hate the idea of having to shop for car insurance. And they don't like, quite honestly, to go to a dealer and buy a car. Now, there are ways to innovate systems that are going to be much more friendly to consumers in that sense. Then get to these market tipping points. We don't have to prove this out for all 3 trillion miles to prove that it works. We can get to some small communities, put all of these pieces together, and begin to show at a full-scale prototype of the system what might be possible and begin to learn with real consumers and real suppliers. Bottom line is you've got to do unto yourself before others do unto you. Mobility is transforming. I don't think we can hide from that fact. And I do think the companies represented in this conference are in a very exciting position because your skills at designing and manufacturing advanced electronics, doing it with extremely high quality, reliability, and durability, driving down the learning curve so that you can get the costs out of these systems, all of those are going to be major enablers of the future that we see for mobility. It's all about relationships. I joked about my wife a little bit, but we really do have a great relationship, and we often get asked, what's the secret? And for us, we go out to dinner twice a week. Some good wine, quiet music, candlelight, soft, relaxing walk home. I go on Tuesdays, and she goes on Fridays. So with that, I'll end. I'm hoping we have time for a few questions, and I might need some help with the questions. Thank you very much. How's the vehicle performance?
Snow. Icy
roads,
roads, bad weather.
Yeah, well, you led with the one question I don't have a good answer for. Right now, the snow is the impediment with the driverless vehicle. We'll work on that. I think we'll find ways to get through that. But right now, I don't think we would be certifying these vehicles on snow. The good news is, for a different purpose, I looked at cars around the world and the environments, the climate that they're exposed to. Over half the cars in the world never see freezing temperatures. So there are big markets out there where there's not snow, but snow is a problem, yes.
As a part of this study, did you look at the geographically challenged outliers, the people that live in very rural, very poorly distributed areas? Yeah,
another really important question. What I showed here with shared driverless vehicles is not the solution everywhere. You need a critical level of travel density for it to work. The good news is that it doesn't have to be that great, but the rural area where people are far apart, this kind of a concept is not suited for that. But higher densities, we've looked at, for example, Palm Beach County in Florida is ideally suited for this. These medium-sized cities or larger cities, but rural areas, no.
Yeah, it would seem to me to feel safe driving in a 500-pound vehicle, I'd want to make sure there were no 2,000-pound vehicles being driven by teenagers who were texting. So in order to achieve these wonderful efficiencies, it seems you'd have to get all of the drivers out of all of the cars. Is that in the plans, or how will we deal with that mixed time where there's some autonomous vehicles and still a lot of human-piloted vehicles?
Yeah, I think it's important to manage that transition. I'm optimistic that when we show the safety benefits of connected and self-driving and driverless technology, the government is going to step up and say, we really want to take advantage of that. Who would have ever thought smoking and secondhand smoke would transform as fast as it has in our society as we realize the safety risks. With that said, there were two mainstream approaches, and they're still there. One was to try to get to this future with cars talking to each other, connected vehicles, transponders. And in that case, we had to have all of the cars equipped, and we were concerned about that. What Google's doing here is they're allowing an individual car basically to be a robot to see everything going on. And in fact, that car you'll be more safe in, even with teenagers around you texting versus driving it yourself, because you're getting a 360-degree picture. The difference is in the mass of the vehicles. So that ultimate transformation to the small vehicle is one that's going to have to occur in communities where we've gone out into the transition further in time. Part of what I'm doing here is showing the potential that we have by moving forward aggressively on driverless vehicles. And we'll try it out in different places.
Right front. Larry.
Larry.
Oh, I'm sorry.
Right here.
Oh, I'm sorry, yeah, okay.
What about car guys that actually want to drive themselves?
Yeah, I think we've thought about that a lot. I happen to be one of those people, and we're certainly not saying you can't drive. That's not what we're saying. It had to be interesting back in Carl Benz's days when the automobile first came out. There were a lot of horse guys out there too, and they loved their horses. They loved riding their horses, and even today, we still see horse enthusiasts and horse racing. So we don't want to take that pleasure away from people. A lot of the car guys I talk to typically will admit there's times when they don't like driving. They're off of work, it's late, they're tired, the freeway's backed up, and they like to just hand the driving over to somebody else. But we don't want to prevent people from driving.
Hi. In the example of the car that you showed, there was a lot of data that the car was collecting. So I'm assuming that when you set up this huge network, you're going to need very large data centers. Have you looked at the cost of building up large data centers and then maintaining data centers?
I personally have not looked at those costs. I think that's an interesting question. I think that's part of the reason I think Google's involved in this technology. You might say Google's not a car company, but the future that we're looking at is a very data-intensive future. Talked about how much the lasers are measuring per second. The cameras are even more than that. And the Street View databases are all massive. Again, that's not my expertise. I suspect people inside of Google are talking about the questions of the right approach to data centers for this.
Good morning. I have a question. Will there be a mechanism in these vehicles to override the speed limit?
Oh, yeah. The development vehicles have this great big red button right here on the console that you hit, and they immediately are overridden. So that's how we will develop this. We'll take cars as we've known them, we'll integrate these components, and we'll continue with the learning curve. The point is, and because I get to experience this on a fairly regular basis, each time I get in the vehicle, I like having the car drive itself. I'm not nervous about hitting an override. I've had enough experience in the car, even to the point where I might be in a lane of 101 and the car in front of me slows down. If I was driving myself, my first tendency would be put a turn signal on and get into the other lane and pass that slow car. My tendency now is just sort of kick back and relax. Don't worry about it, because there's somebody that's controlling that flow. But yes, there's override buttons, and you'll have choice.
Can you turn it up? Go ahead.
Go ahead.
I have a question about the Ann Arbor data. You had 200,000 people with a car that use it about an hour a day. So how did you calculate that 18,000 vehicles could replace if those 200,000 or 180,000, let's say, need it from 7:30 to 8 in the morning and 5 to 5:30 at night?
Well, the fact is the 200,000 are not all on the road at the same time. In Ann Arbor, there was a peaking at about 13% of those 200,000 cars were on the road at peak hour. One thing which I didn't say, I should have said it, I went over it pretty quickly. We removed the really long trips from the Ann Arbor database. So any car that was being driven more than about 100 miles a day, we removed, because these are typically people who are driving outside of what's called the Ann Arbor metropolitan area, which is Ann Arbor, Ypsilanti, Chelsea. And so we actually were focused more on a smaller number of cars. But the point is, not everybody's using their car at the same time. So even though we see peak hour as rush hour and congestion on the freeway, we think everybody's out doing something at the same time. In fact, the data tells us it's usually less than 15% are on the road, even during peak hour. So that's how we're able to replace that number of cars with a fewer number. Those cars, by the way, are utilized about 80%. And those cars that are shared will have about 200 to 300 miles a day put on them, whereas today our typical cars are about 40 miles a day, 40 to 50.
Yes, has there been any research of consumer attitudes toward this? Maybe this is something that comes from sociology departments rather than engineering departments, but is there any indication that consumers will accept this if it does make financial sense?
Those programs are bubbling up now. I think for many of you who have been following the media on this, it's been getting quite a bit of attention. At the University of Michigan, we're kicking off programs on exactly those kinds of questions. What are the consumer experiences that will resonate with people? What we do know in consumer research is time is an extraordinarily important driver for people. So that's why they're texting and using their cell phones, and they're concerned about their driving time. We also know that when we can deliver very exciting experiences, things that people haven't even thought of. So one example might be you're in a driverless car, you're headed to a restaurant. The restaurant, let's say it's Shula's Steakhouse, knows you're on the way, and within 5 minutes of your destination, they ask you, what would you like for your drink or your salad or your appetizer, and they could have it on the table before you arrive so that they can turn their tables quicker. Or you're headed to a mall, and they can contact you and try to get a sense of what you might be shopping for, or give you other kind of entertainment experiences. So have we answered the question with real people, will they buy this or not? No. Do we have a lot of research that suggests people would like to use their time when they're driving differently than driving? We know that for a fact, and we know that people really gravitate toward exciting products. The good thing is we can try this at a small scale and learn about the consumers and get it perfected before we scale it.
Continuing off the last gentleman's question, it seems to me the challenge is going to be political.
They always are political, and that's fine. And that's why in my earlier slide, I think the engineer says the technologist close to this technology, 3 to 5 years we can make this work. You also have consumer acceptance, we also have regulations, and we also have liability. The insurance companies have a big stake in the game. A typical car costs about $800 to $900 a year to insure. If you're in a shared vehicle world, you're not incurring that cost, so the role of insuring the mobility system changes. I also didn't talk much about freight, but one of the reasons the trucks are as large as they are is because of the cost of the driver. If you can begin to think of freight movement systems that are driverless, suddenly we can start moving our loads to be much smaller. That has a systems feedback into how we design the roads and bridges, very much into your supply chains and how you manage your supply chains. So we do see big opportunities here. I keep going back to 3 trillion miles and a penny a mile. Another way to think about that is 3 trillion miles and you get a 10% share of the miles. So we don't have to excite everybody. We don't have to excite the car enthusiast necessarily. But if I can get a 10% share of those miles, so I get 300 billion miles and I make 10 cents a mile, I'm also at $30 billion a year. And that 10 cents a mile feels like it's within our reach when people, the median income person, values their time at 85 cents a mile.
You mentioned that there's a lot of car companies that are on the forefront of this, but in your Ann Arbor example, you're moving from 200,000 vehicles down to 18,000 vehicles. How are they motivated to sell less vehicles?
That's the innovator's dilemma. And for those of you who haven't read the work of Clayton Christensen on the innovator's dilemma, or this point that I made here, do unto yourself before others do unto you, you can kick back and say, I don't like that, and hope it'll go away, or you can get in front of it and lead the change. Keep in mind, these shared vehicles are accumulating miles at a much faster rate. So the modeling we do, we're assuming people are traveling just like they are today. So the number of miles traveled does not go down. So if you think cars are depreciated through miles, then it's a wash. Those cars, though, aren't going to be highly differentiated the way we see in the industry. They may be used up in 3 years of high usage per day versus 10 or 15 years of low usage. So it's a big change for a business model that's used to investing $500 million in a new car program, engineering that over a 3 to 4 year period, launching a brand new plant with new tooling, getting your dealers motivated to sell it and sell that car for 6 years and maybe see me once every 6 years. That's why the auto companies have got to get serious about selling, in addition to cars, seeing if they can position to sell miles, trips, and experiences.
Having been in Ann Arbor for 4 years, did you delete the data for football Saturdays?
Well, for a while, we were such a poor team, we weren't having people show up. But no, obviously, the way we frame this study is there's the typical everyday getting around on campus, and then we're going to have solutions for peaking. The thing is, there's a lot of land in Ann Arbor that's sitting there idle most of the time that's used to park cars during football Saturdays. And it's just remarkable to me to see how much land is consumed in parking. I happen to be on the board of a real estate development company. I'm just amazed at every project they do, commercial real estate, how much land they set aside for parking of the cars.
I believe the history of in industry shows that whenever there's a new technology, that the old companies never succeed. Do you agree with that? In other words, wouldn't this have to be new companies?
Well, the only caveat I would put on never, because I went back, one of the hats I wore at GM I was responsible for strategic planning, so I went back and read all that literature because I was seeing the exact same pattern. I did find a couple. IBM did not go away, so they were one company that has found a way to transition their business models and make it through. But I would say the odds are way higher than 90% that an incumbent is going to have a tough time dealing with the disruption of the type that we're talking about. And that has something to do with the financial institutions. It has something to do that these incumbent companies, you take an auto company, they have deep expertise in mechanical drive, they have deep expertise in combustion engines, they have massive capital investments in assembly plants that are welding together cars that have already defined architectures. And the ability to shift all of that when you're just barely eking out enough profit to generate enough cash to get to your next model cycle, that's the wall you run into, is where do you get the resources to change? A startup can come in underneath. They don't have all that legacy cost. They're quicker. They fail a lot, but they fail small. And next thing you know, they get it and scale. That's one of the reasons I'm here today. Some of you are large incumbents, others are startups. My prediction is the revenue of 3 trillion miles a year, which is about 60 cents a mile in total. So $1.8 trillion of revenue is in play. Whether you're an insurance company, an electronics company, an auto OEM, a cab company, a trucking company, it's in play. And the technology, the business models, and the system design tools are coming together along with big data systems to really disrupt that. So thank you very much for your attention and enjoy our conference.